Then to find the components which you will be using, which is the logic gates, you can find them by expanding the libraries of Altera as shown here. So you expand it, you'll find three options: mega functions, others, and primitives. So all the logic gates and the input output ports can be found under the primitive folder. So expand it and you can see another 5 subfolders, which is the buffer, logic, other, pin, and storage. Okay, so these logic gates will be under the folder of logic. So once you have expanded the logic, you can see there are lots and lots of files which are representing each component. Okay, for example, here you have N12, N2, N3, N4, and so on. Okay, so you can check on them what are they by clicking on their name, and the diagram here will show how exactly they look like in the software. So basically, N2 stands for AND gate with 2 inputs. Okay, N3 is AND gate with 3 inputs, and you can find everything in there. So as shown in the diagram before, we are using the 2 input AND gate. So click on the name and then click OK so that you can place them here. Right? So notice that from the diagram, you are using two input AND gates. So place 2 of these gates together. Okay, and then to end it, you have to right click somewhere on the interface of the software and then click on cancel. Right, so now as you can see, there are 2 AND gates with 2 inputs in your circuit, and then you still need another 3 gates, which is the NOT gate, 2 of them, and then the OR gate, 1 of them. Okay, so you still the same way, still can find them through this button, symbol tool, and click on it, and then under the same subfolder of logic, look for NOT gate. Okay, so once you click on the name, you can see how the actual gates look like here. Alright, so that is how it looks like. So this is the gate actually that you are using. So select on it and then click OK. Okay, same as how you place the AND gates just now. So now you use the same method to place them anywhere on the software first before you end the selection. Okay, so this is the second one. Alright, and then I want to end them, so right click anywhere on the software and then click cancel. Okay, so now you have already got the first four initial gates, the 2 NOT gates and 2 AND gates. Right, so as you can see now, I highlighted all of them together. Alright, so that it is I can use these highlighted gates for easily moving them. So just pull them to where you want to place them to make them look neatly. Alright. Okay. So it is up to you how do you want to arrange the position of the gates. But actually the position doesn't matter as long as the connection is correct, then it is okay. Alright. Okay, so we go back to the diagram here to look back on the connections. So as you can see here, the first AND gate, one of the input came from X1 and one of the input came from X2, but the X2 input is inverted first before entered the first AND gate. Okay. Same applies to the second AND gate. One of the inputs comes from X2 and the second input comes from X1. But the X1 input is inverted first before it is entered to the AND gate. Right? So back to the software. Try to make the connection on how shown in the diagram. But first of all, as you can see here, we only have these 4 gates. We don't have the input port for X1 and X2 yet. Okay, so how do you import the X1 and X2 input? Still go to the symbol tool, click on it, but now you close the logic folder and then you expand the pin folder. Alright, so here you can see there are 3 selections: variable, BDIR, input or output. So obviously X1 and X2 will be the input ports and F will be your output port. Okay, so click on the input port and then click on OK and place them somewhere here. Alright, where it will become the initial input of your circuit. Okay, and then the second one here. Alright, so you have 2 inputs, X1 and X2. So you can use them, these pins, to represent both of the inputs. And then to end them, click on cancel. Okay, and then refer back to the diagram. Here we still need one more gates, which is the OR gates, and then the output ports for F. Okay, so we go back and we look for the output port and place them here, because this is where your output of F will be obtained. And then click on cancel, and again look for the logic, because I forgot to bring out the OR gate just now. So bring the OR gate and place them before the output port, and then click on cancel. Right, so as you can see now, I'm arranging them so that it is easier for me to make the connections as how shown in the diagram. Okay, so I check back and I want to make sure how the connection should look like. Okay, how are the inputs of each gates and where the output will be going. Okay, right, so now I'm about to connect the gates here, but first I would like to arrange them like this. Okay, then now the first input pin, which is X1, will be the first input for the first AND gate. So you just make the connections by pointing at the end of the input port and click on it and drag them to the input port of the AND gate and click on them. Okay, so you should see the blue lines, which indicates that there are connections between the first pin input and the first input of the AND gate. Right, and then you may repeat the same method for all the other gates until you have created the same connections as shown in the diagram just now. Okay, so as you can see here, this NOT gate, you can rotate them to make it easier for you to create the connections. So here I rotate them by 90 degrees, and I place them here so that the input of this NOT gate will come from X2 and the output will be connected to the second input of the first AND gate. And then for the second AND, I will rotate 270 degrees, and I place them here so that I can make the connections where the input will come from X1 and the output will be connected to the second input of the AND gate. Okay, and then you can arrange them as how you like, as long as they are neat. Complete for the next stage for the input of the OR gate. Okay, alright, then another one. Alright, perfect. Then the output port of F connected from the output of the OR gate. Okay, so here, as you can see, the circuit is completed, and you can compare with the diagram here. Okay, so basically, of course, it doesn't look alike in terms of the arrangement and the drawings, because this is just a basic drawing by using writing softwares. Okay, but as long as the arrangement is similar, then there are no problems. You can proceed with the next step of designing this circuit. Okay, now you want to change the name of the input. As you can see here, for the first input port, it is named as pin name. So we want to change them to become X1 and X2, and then the output becomes F. So you double click on it, on the pin names, change pin names to become X1, then click OK. And then the second input port, change it to X2, while the third one, change them to F. Okay, and now you are ready. Just have to make sure the connection is correct, all the name of the input and output ports are correct. Okay, then we can save them so that you can compile to check whether there are any problems with your circuit. Okay, when you have saved them, click on Save As. Make sure the name here is the same name with the one that you have created during the new project wizard just now. So let it be test. Okay, same name, and click on Save.